My name is not important. You couldn't pronounce it anyway. Call me the Observer. I have been watching your planet for 4.5 billion years. That is not an exaggeration. That is not a metaphor. I was there before the first rock cooled, before the first ocean filled, before the first thing that could be called alive moved in the dark. I didn't want to come here. My supervisors gave me the assignment. Go, they said. Watch, document, do not interfere. I asked, why this planet? It looks violent, unstable, not promising. They said, that's exactly why. So I went, and for the first billion years, I regretted it. Let me tell you what actually happened. Your Earth formed approximately 4.54 billion years ago. That is not a guess. That is measured by uranium-lead dating in zircon crystals from Jack Hills, Australia. I watched those crystals form. For the first 500 million years, this planet was unrecognizable. The surface was magma, oceans of it. Temperatures reached 2,000 degrees Celsius. Asteroids the size of cities slammed into your planet every few thousand years. The atmosphere? Toxic. Mostly carbon dioxide, methane, ammonia, almost no oxygen. On my world, we would have classified this as a failed planet and moved on. Then came something I did not expect. Around 4.45 billion years ago, a Mars-sized planet, scientists call it Theia, collided with Earth. Speed of collision? 40,000 kilometers per hour. Debris thrown into space, enough to form your moon. Time for the moon to form from that debris? Less than 100 years. I watched the debris circle your planet, then coalesce, then hang there. Your moon. At first, it was 10 times closer than today. The tides? Violent, hundreds of meters high, crashing into shores that did not yet have any life to witness them. But that collision changed everything. The moon stabilized your planet's tilt. Without it, chaotic seasons and extreme climate swings. With it, life could evolve. I did not know yet that the best part was still to come. I just saw a smaller rock circling a larger rock. I was not impressed. Then, something shifted. Cooling began. I watched water vapor condense. Rain fell, not for years, but for millennia. The entire planet was a storm. And slowly, the oceans filled. At first, the oceans were sterile, just chemistry. Temperatures reached 100 degrees Celsius. Highly acidic, iron and magnesium dissolved from rocks. But then, I noticed something small. Not life, not yet, but chemicals were arranging themselves. Amino acids, lipids, nucleotides, the building blocks. I filed a report. Planet Earth, chemistry becoming interesting. No life yet. We'll continue watching. My supervisor replied, unusual. Then, between 4.0 and 3.7 billion years ago, something happened that I still cannot fully explain. Deep in your oceans, chemicals began to organize, not consciously, not intentionally, but they started making copies of themselves. You call them LUCA, the last universal common ancestor, the ancestor of everything alive today. Microscopic, 0.3 to 0.5 microns. DNA capacity of 2,000 genes. Humans have 20,000. I watched those first cells divide. 1 became 2, 2 became 4, and then, for the next 3 billion years, it was just single cells. It was the most boring assignment I ever had. If Earth's history was 24 hours, life appears at 4 a.m., multicellular life at 8 p.m. But then, around 2.4 billion years ago, some tiny organisms changed everything. Cyanobacteria. They did something new. Photosynthesis. They turned sunlight, water, and CO2 into energy. The byproduct? Oxygen. At first, it was barely detectable. Then, disaster struck. You see, back then, most life was anaerobic. Oxygen was poison to them. I watched entire branches of life suffocate. 90% of all life died, but I also watched the survivors adapt. The oxygen reacted with iron dissolved in the oceans, creating the first rust at the bottom of the sea. Banded iron formations, layers of rust enough to form mountain ranges. Those red rocks you see today? That is the scar of the first mass extinction. After 2 billion years, I filed my first major report. Survival of life, 4 out of 10. Adaptation to oxygen, 7 out of 10. Overall potential, 6.5. I wrote, "This planet is slow, frustratingly slow, but it does not give up." My supervisor replied, "Continue monitoring." I did not know yet that the best part was still to come. Next time, I will tell you about fire. You think you know that story. You do not. I was there. You waited almost everything to discover something I had since my first day, and yet you made it beautiful and terrible. I am the observer. I have been watching. Thank you for listening. In 8 minutes, you lived through 4.5 billion years. Next time, fire.